Kia ora Year 12 and 11. Here's the last question from the summer 2019 A-level papers on vectors. It's question 10 from paper 33. Two parts to the question as usual. We've got a line with the following equation, and then we've got a point. And we have to find the length of the perpendicular from P to that line. So here's the line, here's the point P, and we have to figure out where does it meet at a 90-degree angle. We're going to call that point X, and then we're going to find the length of PX. The next part of the problem is related. We're told that the line L from up here lies in this plane, and A and B are constants, and we have to figure out what they are. So when I see that, here's how I think about the problem. I've got two constants here, A and B, so I'm going to need two pieces of information to help me find them. And one of them is going to be probably to find a point that we know is on the line L. And then maybe we could just find a second point, but let's have a think about that when we get back to it. So the first question is one where we need to just set up the vector Px, and then we're going to find its length. So P is, well, from O to P, if we want to be proper about it, the position vector OP is 4, 2, negative 3, and the position vector of X is 1 plus 2 mu, 2 minus mu, and 3 minus 2 mu. So, going from P to X is going to have this vector, so it's going to be starting here and taking away my starting point of 4, so 2 minus mu minus 2, 3 minus 2 mu minus negative 3. That gives me negative 3 plus 2 mu, and so on, negative mu, 6 minus 2 mu. Right, so we know that Px has to be perpendicular to the direction of that line L. So we're going to use the dot product equaling 0 property from AS. Right, so let's work that through. Well, that gives me 2 times negative 3 plus 2 mu minus negative mu minus 2 times 6 minus 2 mu is equal to 0, right? So what am I doing there? Well, that's my Px vector, and I'm dot producting it with that. Negative 6 plus 4 mu plus mu minus 12 plus 4 mu equals 0. Now, a couple of you have emailed me saying, Miss, how can we make fewer mistakes in our working? And I think one of the things to have some systems for is when you've got a messy thing, but an easy thing like this, just be really careful with how you work this through. So we've got 4 mu, plus mu is 5 mu, plus 4 more mu, that gives me 9 mu. And do something like putting a little tick under each of those as you've done it. And now we've got minus 6, minus 12, so we get minus 18 equals 0. Right? So we get mu is equal to 2. Now, what did we have to find? Well, we had to find the length of the perpendicular from P to L. So all we need is, we don't need the coordinates of X in particular, although they might be useful later on. But we've got our expressions for the components of Px, and it's this here. So all we want to do is to substitute in mu equals 2 to get that vector Px. So Px is going to equal negative 3 plus 2 mu, which is 4, negative mu, so negative 2, and 6 minus 2 mu, so 6 minus 4. And again, if you're watching this and you're thinking about avoiding mistakes, notice that I did this amount of substitution in here. I didn't jump straight to doing this in my head, because I will go wrong if I try and do that. I know some of you won't, but some of you will. So now we find the magnitude of that vector, and it's 1 squared plus negative 2 squared plus 2 squared. Again, just for working purposes, notice that I've put brackets around my negative sign, because that's a really common place to go wrong. So that gives me the square root of 1 plus 4, which is 9, which is 3 units. So that's the first part of the problem done. Now let's look at that second part and see what we had to do. Well, we're told that line L lies in this plane. So here's line L here, and A and B are constants. Well, we know one point that's in that plane because it's given to us in the equation in the vector equation of the line. So if that point lies in the plane, it has to satisfy the equation for the plane. Okay, so 1, 2, 3 is in the plane. That means that A plus 2B plus 6 must equal 13. So A plus 2B is equal to 7. Right, now what can I do to find another equation in A and B? Well, the way I did this, so the easiest way to do this is probably to find another point in the plane, but I want to give you another idea to think about, which is that if the line L is lying in the plane, then the direction vector of this line must be perpendicular to the normal vector of the plane. And the normal vector of the plane is A, B, 2. So I'm going to do get my second equation for A and B by using the fact that the dot product of this normal vector with this direction vector has to equal 0. Right, and I've got a big mess here. I'm just going to give myself some space. So you can try that while I'm cleaning up the tablet whiteboard. And I'm going to put a little bit of communication for that. So L is in plane. So its direction vector is perpendicular to the normal vector. And that tells me that 2, negative 1, negative 2 dot AB2 is equal to 0, giving me 2A minus B minus 4 equals 0. So I've got B staring me in the face here, so I'm going to write B is equal to 2A minus 4. And now I'm going to substitute this in up here. So A plus 2 times 2A minus 4 is equal to 7. So I can solve that, especially if I get rid of all this from before. Right, so solving that gives me what? Well, I get A plus, so I get 5A minus 8 is equal to 7. 5A is 15. So A is equal to 3. And B is equal to 6 minus 4. Right, from substituting back in here, which is 2. Now, I think all I was asked for was the values of A and B. But we could now just go on and write the equation of the plane. So the equation of the plane would be 3x plus 2y plus 2z is equal to 13. But your 5 marks were got by just getting those values of A and B. So there you go. A really nice question, I think. And it shows you there are only so many different skills that we've got with vectors at this stage. So it's just a matter of thinking about what we know and always drawing a picture here. So if you didn't see what to do in here, if you just draw this plane, draw the plane, and then just draw a line through it. And I think that shows you that if you have a point there, it must satisfy this. And then you can also think about the normal vector to that plane, always a good thing to think about, or you can think about a second point on that line. Right. So that's all for now. Tomorrow I'm going to start doing some complex numbers videos. Thanks for watching.